Okay. All right, everyone, let's go. Now, there's a couple of people in the back row. You guys in the back row, do you know to exit that way? Don't walk in front of the camera. Welcome to the second half of week 7. Because if you think about it, we're sort of halfway through the course. If you sort of write off a bit what happened in the first week, we're halfway through the course. So you're halfway through your first semester at university. Now, I know lots of you have physics. The physics exam is this Saturday. Am I right in thinking that? Yeah? And there's lots of assessments due in right now. You've got one due in for this course tomorrow. It's a very potentially stressful time, especially because it's your first time at uni, for most of you at least, and you've probably taken it quite easy for the first couple of weeks, and then now you've quite possibly, a lot of you are feeling a bit out of control and a bit stressed and, you know, struggling for water. And can I just say, struggling for air, that's completely normal. This is what always happens around the middle of semester. And then there will be, the stress will drop off a bit, but it will remain a bit stressful till the end of semester, and then it will all be over. But can I encourage everyone to not give up? Because at this time it can be very tempting to give up, to feel overwhelming and feel you have no control and feel da-da-da-da and panic and just give up. Can I say that you've just got to nut it out for another 6 or 7 weeks and then it's done. And it's going to be tough, but you can do it. And at the end, you'll feel really proud that you did. And if you don't do it, and if you give up, you'll always be a bit disappointed. And I always think in life, every time you give up or you do something you're not really proud of, that it sort of demeans you a little bit in your own mind. I mean, who cares what other people think of? And then that's not good for your self-confidence. And every time you try something really hard and succeed, I think it builds you up in your own mind and makes you a stronger person and a more resilient person. So even if you can't do brilliantly well, who cares? But don't give up. Giving up's bad. So don't think you can't do anything and so you do nothing. Like I know when I'm trying really hard to be sensible and just eat sensible food, and then there's this really delicious pile of Mars bars that I keep taking home because I forget to hand them out in the lectures. And I think, oh man, I'm so hungry and I haven't got any food, and I might have a Mars bar or two. Or two. And then I start feeling ashamed and think, oh, what am I doing? It's so stupid. Oh, it's all so hopeless. And I'm very tempted to give up and then just eat all the rest of the Mars bars. Because I think I've blown it now. I might as well just give up. But it's really important to not, when things are down, to not give up. I think that's really important to do. So can I say uni grades are not like school grades. At school, everyone expects you to get a high mark. And you've probably got this expectation in your mind about what is a good mark and what is not a good mark. And I remember, in fact, in my first year at high school, the first assessment I got back, I made a wooden, crappy teapot holder thing in woodwork. And it wasn't so good and it wobbled a bit, but it was okay. And the teacher said, he gave me 16 out of 20. Now, I took it home to Mum and Dad, and some of my friends got 20 out of 20 and some got 10 out of 20. And I took it to Mum and Dad and I said, this is my teapot holder. And they said, oh, it's wonderful, we really love it. And I said it sort of nervously, I got 16 out of 20. And I remember I stared really closely at their faces because at that point I had no idea whether that was a good mark or a bad mark or anything like that. And Dad just looked at me and smiled and said, 16 out of 20, that's 80%, that's great. And it's weird, that one comment and that smile, just, oh, so relieved. For the rest of my time at school, I had this magic number in my head, 80%. If I ever got 80%, I was like, oh! So you've probably, perhaps not in the same way, got fixed in your mind some sort of compass about what's a good mark and what's a bad mark at school. Let me say, uni is nothing like school. At uni, we have a range of grades. We have a fail if you get less than 50. And then we have a pass if you get between 50 and 65. And then we have a credit if you get 65 to 75, and a distinction if you get 75 to 85, and a high distinction if you get above 85. And if you're back in the school frame of mind, you'll be thinking, I don't know, let me make up something. Let's suppose you got a high TER and you're thinking, I'm like a 90 student. Or you got an OK TER and you're thinking like I'm an 80 student or a 70 student. At uni, it's not like that. If we give you a pass, it means we think you've passed the course. So you've done enough to pass the course. We think you can do the next course. So if you get 50, you've passed the course. So we think 50 is a pass. Does that make sense? At school, if you got 50, you'd be ashamed. You'd say, I only got 50. Because everyone, you just sneeze and the teacher gives you marks. How could you only get 50? At uni, it means a pass. And actually, I look really closely at everyone's exam. And I look at all the people that are borderline. And I spend hours agonising over each individual case, and I'll ring up your tutors to ask them what they think, and I'll pull your assignments out and go over them by hand, and I'll do everything I can, and I'll just try and think, can this student program, have they mastered the objectives of this course? And I'll agonise about that for hours, and then I'll make a decision, yeah, OK, I've seen enough evidence here that I think they have mastered the objectives of the course, and I'll bump the mark up and you'll get 50. Or I'll be talking to the tutor and I'll say, no, I don't think they did. And I'll bump the mark down and you'll get 49. I'll be agonising around this sort of cut-off mark thing. And I put enormous amounts of effort in to make sure that no one ever fails that I think has mastered the course. It would be very easy just to put up with the marks as they are, but I will actually go over the marks. And around that time, and it's a horrible busy time of year, but I will spend enormous amounts of time making sure I fiddle the scaling so that no one that should pass the course fails it. Which will mean, because it's not fair to rearrange the order of students, it normally necessarily means that a few people that shouldn't pass the course end up scrooping by because someone who should pass the course came in slightly below them. And that's just lucky for them. But 50 is good. Now, if you got 65, we'd say that's a credit. And credit means credit to you. Well done. You've not only passed this course, you've done some neat stuff as well. You should be proud for how you went in this course. Now, at school, maybe 75 wouldn't be such a good grade. The 65 wouldn't be such a good grade. But at uni, 65 is credit. 75. What does 75 mean? It means distinction. It means, oh my God, you are awesome at this course. Now, we haven't even hit my dad's benchmark yet, have we? But awesome at the course. You won't get many distinctions. If you get a few distinctions, you'll be really proud and they'll be your best courses. If you get 85, you get something called a high distinction. Now, what that means is you haven't got a life. You have worked too hard on this course and you should be ashamed. You need to spend more time with your family and friends. It's a glorious day outside and there's lots more other things to do. So I don't want everyone stressing out right now. You will all pass. You all have it in you to pass. That is what's required at uni. But a psychology student once told me that there's this thing called the curve of stress. Now, this is like saying they say, because I know nothing about psychology. What I could be telling you could be completely wrong. All I can claim is a psychology student once told it to me. And apparently it goes something like this. Apparently, there's how effective you are, measured in effective units, and then there's how stressed you are. And it turns out for most people, their stress curve looks a bit like this. I don't know if it's actually a normal curve, but it's this sort of shape. So essentially, the idea is, actually, as you increase stress, you perform better. And you probably know that. If you can just bum around and no one puts a deadline on you and no one cares about anything, you're down here. You're sort of okay, but and as you increase your stress, you get better. But the payoff starts to decrease. And there comes a point where as your stress increases even more, you get worse because you start freaking out, you start not trying to learn the stuff but just memorise the stuff, you start panicking, your pulse rate goes up, you can't sleep, you get a cold for your exam because you crammed too much and you got sick. And so you don't want to get too stressed. So if you feel yourself getting really stressed, probably the best thing you can do for your uni and for your life and for your happiness is rather than continue to work really hard and get even more stressed, is just take a break and go for a walk and see a movie that makes you laugh. My wife told me last night, she'd heard, they say, that apparently children laugh like 300 times a day and adults laugh between 50 and 100 times a day. Isn't that sad? Now you guys, you're still on the children end of things, I reckon. Never let go of that. I'm going to hope to be a child till I'm dead. That's my plan. So you don't want to turn into one of those adults that live out here that laugh like under 100 times a day. That's just very, very sad. I reckon every time you laugh, it's got to be good, doesn't it? So essentially, what you've got to do well at uni when things get really stressed is to manage your stress rather than thinking you've got to manage your assignments or your courses or your... So maybe you're not going to do well in an assignment, or maybe you're going to miss something, and maybe you're not going to master every single thing, and maybe, you know, you hand something in late, and maybe you misunderstood the spec and you get it all completely wrong, and maybe, but in the big scheme of things, who cares? What you want to do is be a happy person doing well. A reasonable amount of work, not killing yourself, will pass you in any course. So don't kill yourself. Anything else is a bonus. But absolutely don't get too stressed and burn out and explode, because that's, you know, life's too good to do that sort of thing. Now, what I wanted to talk about today, we've reached halfway through the course, and we're at this really pleasant point where we've now sort of nearly, almost, done all the syntax we'll ever need to do for C. I say sort of nearly, almost, rather, because there are a few little bits and pieces of C syntax we'll still have to cover, but essentially you know all the C you need to know, and now we're in this lovely state, this lovely place where we can start talking about ideas. We start thinking about what to do with C rather than just how to actually use C. So it's like you've learned how to ride the bike without falling over, now we're going to start doing tricks and cool stuff on the bike. So I guess yesterday's lecture where we talked about abstraction, that was probably the first lecture where we really could just talk about ideas and not syntax at all. And it was lovely. And I think that's possibly the most important lecture in the course, that last one. So I hope you're all here for that. If you weren't, you should absolutely watch it, because we're now starting to move away from syntax and just looking at what we can do. And that's just, you know, that's good. Who wants to be a person that knows a whole lot of stuff about syntax? Let someone else be that person. We want to be the people that, given a bit of syntax, can do awesome things. Now, I did want to... I won't play that now. I did want to show you the notes. Let's go through the notes. That was a bit weird. Oh, I'm watching a funny movie here that you can't see. It's great. See, I already got one of my laughs in. I've only got 49 left to go. Okay, now I'm going to show you the rest of. I'm going to show the rest of you in the break. We'll have a little break in the middle. Let's go. So lecturers, do be quiet. No, I can't believe that worked. I'm going to tell other lecturers, and they say, "Oh, I'm worried about people talking. How do you get people to be quiet?" I say, "Do you say do be quiet?" I always tell them, because we have a lot of debate amongst ourselves, lecturers, about how to do this and how to do that and how to teach and so on. And I always say, I reckon the best thing to do is if the whole class is like a collaborative sort of thing and we're all working together and we're all on the same side and it's like a collective sort of thing, then you just sort of don't get people being rude or noisy or disrespectful, except someone up there is talking now. So I figure that's what happens. Better to have things working because people want to make them work rather than sort of having some draconian way of forcing things to work. All right, let's go to Richard's bullet points. Oh, actually, it's called Richard's notes today for some reason. Okay, some quick points that I just wanted to talk about. Notice that there's a difference between 6 with double quotes around it and 6 with single quotes around it. And I guess 6 with no quotes around it. 6 with no quotes around it is a number, the number 6. 6 with one quote on either side of it is again a number, it's a character. But remember, characters are numbers. 6 with double quotes, what's that? It's a string. Now, strings are basically, what are they in C? Arrays. If in your code you're trying to compare something with something and you compare it the wrong way, like you'll do this sometimes. You want to check to see if something's a 1. And you'll say, is it equal to, and you put double quotes instead of single quotes. You get some crazy message and it'll say, trying to compare a number to a pointer, or trying to convert a number. You're nodding because you've had this. Why is it talking about a number and a pointer? What's the pointer thing mean? An array. Because what is an array essentially regarded as by C? Not exactly, but more or less. An array is more or less the address of the first element, a pointer to the first element. So when C sees an array, it's often thinking it's seeing a pointer. Not always, but often. So if you get a weird message about numbers being compared with pointers and you think you're just looking at a character, check you've got your double quotes and your single quotes the right way around. Here's how you compile task 2. Some people have been asking, is that too small? Let me make that a bit bigger. I'm in IE. Oh, I can't make it bigger. Let's just get all closer to the screen. Text size. Don't you hate these cryptic menu items? No, that's very clear. Okay, GCC, negative wall, negative wearer, negative O, call it whatever you want because you're not handing in the executable. I called it Sudoku. Spelled correctly just to throw you all off. In fact, gee, are some of these spelled correctly and some? No, they're all spelled wrong. They're all spelled wrong? Ah, okay, good. Okay, that's how we want it. We want it consistent. So the name of the output file, which here is Sudoku, and then the three files you're going to compile, which are main, Sudoku grid.c, and test Sudoku grid.c. That's how you compile a thing. Don't compile the .h's in there, and don't try and compile them one at a time. It'll grumble. If you try and just compile this one, for example, what error message would you get? It can't find main. And there'd be some weird linker error. It'd say linker error, or it doesn't even say linker, LD error, underscore main not resolved symbol or something. And that just means can't find the main function when it tries to link everything together because there's no main. So put them all together. Now look at this. What's wrong with this diary entry? Here's someone's diary entry. I never know each year how to tell you guys how to do diaries because I can't really release each other's diaries to, you know, I don't know how to do it. Really what I should do is release you some of the previous year's diaries anonymised or something. Because I think the best way of learning is by looking. Certainly once you've marked a diary, you know what a good and bad diary are. Yes?
Some people have been forgetting to make their diaries private.
Oh, you should just tell them if they do that. Does everyone know that? You can test your diary with test student. I thought everyone did that in task 1. What's that?
If you search task 2 on the wiki, there's about 20 entries that come up that haven't been private.
Oh, okay. All right. So thank you very much for saying that. So go in and fix it for those students if you can. You've got, what's that? Your one's there. Oh, no, you can see your own. You can always see your own. Yeah, so he's searching. He can see 20 there already. So do check the same way as we did it for the first task. Log in as a test student and check that the test student can't see your diary. If the test student can see your diary, everyone can see your diary. So yeah, one way of learning how to write diaries, or maybe how to not write diaries, is to look at the ones that haven't yet been hidden away. But hopefully they'll all get hidden away soon. But here's one entry. I discovered that my isLegal function was not completely perfected. After a few changes to each of the rules, it was finally complete. No content. Like, that's not a diary entry. That's just like, don't even bother handing anything in if you're going to say that. I did the assignment and I had some problems and I worked on them and they were solved and it was done. Imagine that. Look, imagine the diary is an ad for a film. You know, imagine the trailer for a film. Dun-da-da, Indiana Jones and the Temple of Doom. A man with a problem, but don't worry, he solves it. It's not informative, it's not useful. Okay, so what we want in your diary is something that tells us what you're going through. So, I discovered my isLegal function was not completely perfected. What does that mean? It probably means you just made that diary entry up. But what you should say is, I ran this test and I kept getting this result. I couldn't work out what it was. I thought it was maybe one of these lines, cut, paste. I hunted around and then eventually, or instantly I saw that, or an hour's work later I realised that this should have been a double quotes rather than a single quotes. That sort of makes sense now I think about it because C regards pointers as ints. So I changed it and it passed that test. Or that is an interesting diary entry. Now the marker knows you had what problem you had, how you went about solving it. The marker wants to see the process you've gone through to write the assignment. So they want to see what you're thinking about, where you're stuck, and then how you have a breakthrough. You go, oh, you don't have to write the diary for hours and hours and pages, but you do have to write more than that. You have to write enough so they can see what you found difficult in the assignment and how you overcame it. Or if you found the assignment so easy that it was just, there was nothing hard about it at all, then gee, what could you write in your diary? Why it was easy? What you did if you're so great. Yeah, what you did if you're so great. I'm sort of thinking no one should find it really easy because there's a bit in this assignment for everyone. So if you find the C coding easy, you might have found the unit testing hard. If you found the unit testing easy and the C coding easy, then maybe you find the idea of backtracking a bit hard to understand. If you find backtracking easy, unit testing easy, the C easy, what are you doing here? Well then write at about... maybe you found writing a diary entry hard. But maybe, I mean, when you see any problem, you have to switch your brain on to solve the problem. And we want to see how you switched your brain on and what you did. I've never approached a problem in my life that I've regarded as completely easy because I'm always thinking, well, okay, let me understand what this problem's really asking. What are the potential problems with this? Now, maybe as a result of asking all those questions, all the answers are what I expected. But still, I step back and I think really hard about every problem. And I expect you to do that too because one day, if you just take things for granted, it'll turn out it's not what you thought. So you've got to have something you can say. You've got to apply some analytical skills to it. Yep. And then someone wrote this: I'm finding the forum to be less helpful than discouraging. Kind of puts me off browsing the forum for answers. See people and their problems make me feel like such a noob. Now, after seeing that, I must admit I jumped straight over to the forum and to just quickly go in and censor and cause havoc and destruction. Because the last thing we want, the forum should be a place where we're all a community and sharing. There are people here who are experienced programmers, and there are people here who have never programmed. There are people here who are feeling confident and bored. There are people here who are feeling stressed out and feeling it's really hard. It's no reflection on you, no matter how you feel. It's just your background and how you got here. But the forum should be a place of help. So one thing I hate more than anything on the forum is people just showing off. And especially if you're an experienced programmer and you're showing off, it makes you feel good, but it can make the other people feel like crap. So I did race over the forum saying, if I can find any showing off, I'm deleting it, or I'm moving it into discussion. Because if you're an experienced programmer, say all your stuff in discussion. Don't say, oh, I thought of this fancy, amazing new way of doing something incredible that uses this really elaborate thing, blah, blah. Don't say that in task 2 help. That's like, maybe I'll have a forum saying, I'm really clever forum, and then you can just post it all in there. So I know you're clever, and I'm not poo-pooing being clever. It's great to be clever, but be considerate as well and think of the other people. So task 2 help is for people that need task 2 help. If it's involving anything that we haven't covered in the course, please put it in discussion. But I'm pleased to say when I went racing through the forum, I couldn't see anything bad. In fact, I saw a whole lot of helpful people, and I saw a whole lot of smart people being gentle and kind and helping other people, and it made me quite proud. So well done. So whoever this person was, they probably went there on a bad day and they might have seen some posts that I haven't seen. Or they might even be really, really stressed, so everything's stressing them. But I must say, I was really pleased when I looked at the forum. But let me do say, just preemptively, because we've got a project coming up, and I haven't really seen much of that in this course. Normally, it happens a lot in the first year course. This year, actually, everyone's been good. There's virtually been no showing off at all. So I really like that. That's really cool. And the smart people are, and not the smart people, I shouldn't say that. It's really just the people that know more. Smartness doesn't really enter into it. It's just knowledge. The people that know more, as far as I can see, are really helping everyone else in a really kind way. So that's really good. And I often think a student helping a student is much better than me helping a student, because the students know what it's like to be a student, and students coming from a student point of view, and student grappled with this problem themselves, maybe a year ago, maybe a day ago, maybe when they were teaching themselves programming 6 months ago, whatever. They've grappled with this problem more recently than I have, and they can maybe think of a cleverer way of explaining it, or a more appropriate. So I like it to see people helping each other. It's great. Well done. Now, I wanted to give you a puzzle. First of all, we did talk about the weighing puzzle, and I did see some answers posted on that. Please don't post answers, because I reckon puzzles are beautiful things, and they give you enormous joy when you solve them. And if someone else solves them and tells you how to solve them, you know, it takes that joy away from you, and you can never have that joy because someone said you the answer. Unless you're forgetful like me, and then you can solve puzzles 50 times because a week later you've forgotten how you solved it, or even that you saw it. In fact, there's a funny Woody Allen film, I think, where he's standing in a line for a movie and the person in front of him is being really pretentious, giving away everything that happens in the movie. Have you guys seen that? Yeah. Is that Annie Hall or something? It's hysterically funny. Yeah, YouTube. Yeah, that movie. So here's the weighing problem. Now, remember the weighing problem was to get these, I won't specify the whole problem again, but essentially you wanted to weigh a whole number of kilograms, and you had to buy some weights, and you wanted as few weights as possible to weigh things. And look, people tried trial and error. Then someone noticed that essentially if you're putting all the weights over here and your object to be weighed over here, then you've got a choice. For every weight, it's either there or not there. So if we encode a weight as being, let's suppose we've got 4 weights, A, B, C and D. Every item can either be there or not there. I'm going to encode being there as a 1 and being not there as a 0. So every combination of weight is just an arrangement of 1s and 0s. Now, how many arrangements of 1s and 0s are there with 4 items? 16. So the best we could hope for is to weigh 16 different weights, and that straight away sort of shows us it's binary. Can everyone see that? So that sort of suggests that our weights should be, I mean, this is how the binary system works, 1, 2, 4, and 8. And a lot of people noticed it was binary, and that was really cool. And then and the nice thing about this problem, I should say, this is a problem that it's not a fantastic problem, but it's a problem I like because I invented it accidentally because I was trying to teach binary to some Year 6 kids. So I sort of was thinking of sort of expressing it like this. And we did the whole thing, and I showed them that, and they eventually all worked it out themselves, actually. I didn't show them anything. And I went home, and I was in the shower thinking, how nice, that was really good, that was an effective way of showing binary. Next week, I'll show them a proof that there's no way of getting better, because we showed that binary worked. I'd like to prove that that's the optimal solution. And I'm having the shower, and I thought, hang on, you could put the weights on both sides. That's not the optimal solution. So the next week I came back and said to them, actually guys, there's a better solution to this problem. And we looked at putting the weights on both sides. Well, they worked it out eventually and put weights on both sides. And da-da. Now, if you put a weight on both sides, then your weight's either absent on the left or the right. So we could say absent left or right, or I could encode that as 0, 1, or 2. So for every weight, it's either got a 0, 1, or 2. How many different combinations of them are there? Well, you'll pretty quickly see that's base 3. Can everyone see that? So there's a base 3 representation of putting it on both sides. And that's really cool too. And some people eventually discovered that. And what I like about this problem is you can think you've solved it, and then you go away, and you think about it some more, and you get a better solution. So I was in the shower that night having a shower, and and I was thinking, I played the guitar in the shower, and I was thinking, oh, that's so cool, and I really liked the way we thought we'd hit a perfect solution. We hadn't. I also quite liked the way that I could show them that I had thought I'd worked it out, and then we all found a better one, because I like sort of empowering the students to show them just because I think I've got the answer or an adult says something's the answer doesn't necessarily mean there's not a better answer if you keep looking, so never give up. And I was thinking, now how can we prove that that's the best possible answer, because I am a mathematician, I wanted to prove it. So I thought about it and thought, oh, actually we can do better. Is that why you're waving your hand? Yeah. No, don't say what it is, because I want to leave it as a challenge. I don't know if it's been said on the forum, and if it hasn't, please no one post it. You can do better than that. Okay, and when we work out the third way, what's to say that I'm going to be in the shower after that lecture when I'm playing the guitar, and I'm not going to go, oh, hang on, or better still, you guys might all be having showers. You should, it's really fun. And you might think of a fourth way. And how do we know that's the best? We don't. Okay, so I hope that it's okay. So don't say your way, and well done for thinking of a better way. Tell me privately, sort of, oh, it was you. Sorry, tell me privately when we're offline, like, just tell me what. But you can do better, yeah, that's right. So the puzzle I wanted to give you today to think about was a triangle puzzle. And it works like this. Some of you might have already seen it. Please don't call out or give away the solution if you know it. The triangle solution is you've got a triangle labelled ABC on the corners. And you've got a 3-sided dice. Now, we've got a bit of a problem here because we don't have a 3-sided dice. We could use a 4-sided dice, and do people know that there's like 6-sided dice and 4-sided dice and 12-sided dice? Most dice are made out of, are called platonic solids. Do you guys know about platonic solids? Platonic solids is a 3-dimensional shape whose faces are regular polygons. And regular polygons are, well, the 3-sided one's an equilateral triangle, the 4-sided one's a square, the 5-sided one's a regular pentagon. So a dice with rectangles in it's no good, but a dice made out of all faces being squares is obviously symmetrical in some really pleasing way, and it's more likely that every side's equally likely. You can make a dice just out of triangles, it's like a triangular pyramid. You can make a dice out of hexagons, it's like a soccer ball sort of ish thing. You can actually, by assembling triangles in different ways, make larger shapes, and there's actually 5 or 6, I can't remember the right number, of platonic solids you can make dice out of. And you can prove, it's a very simple proof that there are no more platonic solids than those. Platonic because I think Plato invented them, or discovered them, or noticed something about them. Okay, so unfortunately there's no 3-sided platonic solid. The smallest we've got is this 4-sided tetrahedron. You could throw a 4-sided one and discard one, but what's a better way? A 6-sided one, and let's say 1, 2, 3, and we'll call 4, 5, 6, 1, 2, 3. We'll mod it by 3. So you could use a 6-sided dice. Though this raises an interesting question, how could you get like a 5-sided dice? And I'll leave that as a puzzle for you. So I brought a 6-sided dice. Now, we're going to say that they're, in fact, I brought 3 of them. We're going to say that one side's A, one side's B, and one side's C. We're going to start with our little dot, and we're just going to play this game. Throw the 3-sided dice. I'm not actually going to do it. Oh, well, actually, I will. Can you throw the dice and tell me if it's A, B, or C? Oh, you keep it near you because I'm going to get you to do it a couple of times. Yep, what is it, A, B or C?
What do you mean?
Imagine your own way of assigning the numbers A, B and C to those numbers. Maybe we'll say 3 is C. So we could say A's 1, B's 2, C's 3. Okay. And then 4's A, 5's B. Don't do that to me. And 6 is C. Yep. Does that make sense? Yeah. So what did you get? C. All right. So this is our starting point B, let's say. I'm going to go halfway towards C. And I'm going to put a dot there. And this is my current starting. All right, now do it again.
I got 3 again.
3, oh, C again. All right, so I'm moving halfway towards C and I'm going to put another dot. Do it again. We're going to do about 5 times. B. B. Oh, okay. Oh, so we're moving halfway back. Oh, that's confusing. Gee. Okay, let's say that's it. Oh, man. Okay, we're moving to here. What are we all hoping for? Lie next time. Okay. No matter what you get, say it.
1.
Hey, okay, good. Where were we? Here or here? Here? All right. So we go halfway towards A, so we put a dot here. Does that make sense? This is the triangle game. Now we're going to keep playing this game, and we're going to play it for thousands and thousands of throws of the dice. It's too boring to do, but you could easily write a computer program to do it. My question to you with puzzle 1 is, what's it going to draw? Now don't say if you know what it is. Don't say what it is. Puzzle 2, the snake. Here's how a snake is defined. A snake is made up of segments. Each segment is 2 squares, like a domino or something. We're going to say that we're going to start counting from 0 because we're programmers, remember. So we're going to say this is square 0, this is square 1. Oh, I'll do it on the thing. I'm going to say this is square 0, this is square 1. Does that make sense? Square 2. And the snake is, we're going to look at our little dominoes of 2 things. The first is going to be a value. So this domino has value 4. And the second is going to tell us which domino to jump to next. So we're going to jump to the domino at 10. Where's that? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to jump to this domino to get the value 20 and jump to the domino at 14. Does that make sense? And as we wend our way through this, this forms a snake. And my challenge to you is, only using your eyes, how long is the path that we're going to have to follow till we get to one that points to 36? Yep. So you'll notice there is no domino 36. So as soon as you get to one, suppose it was this one, suppose we landed on this domino, that would be the end, because it has value 0 and 36 is the end. So my question is, starting here, how long is the path to get to a domino with the 36 as its as the pointed to the next domino? Does that make sense? Don't want you to tell me the answer. You've worked it out. Well done. Oh, is it a question or an answer? You're awesomely impressive. Because Thurston was showing me that this is a puzzle that has distractors. This measures something to do with your executive functioning of the brain. That with lots of extra data here, it's distracting and it's hard to concentrate just on the one bit you need. What's that called, Thurston? That's deletion. Is that deletion? It's access. It's access. So this is an access puzzle. You've got to somehow ignore the bits. It's very hard to do. So let's leave that there as a little puzzle. And I wanted to show you some C code. So when I say leave it there as a little puzzle, what I actually meant was take it away and show it to you later. Oh, here it is here. Again, but that's only briefly to taunt you because we're about to jump into writing some C code. There's one little bit of C syntax I want to show you because we're going to be using it next week. So let's go File, New Project. Oh, what's all this? Command line utility. This is just an Apple thing. You guys don't need to do it, you lucky things. I have to keep saying this. Project name, let's call it, I'm going to call it structs. Struts. Structs. Choose. Finish. And we've got a function called main, a file called main. Here we go. Here's our structs code. Now, remember we've talked about functions just returning one value and how nice it would be if they could return more than one value. And we've seen that we can sort of sneakily return more than one value by having a var parameter, by using pass by reference and pointers and things like that. Well, let's suppose we didn't go down that path at all. Because in some languages they don't. In some languages you can't change parameters. How do those languages have functions that can return more than one thing? Because sometimes you want to return more than one thing. Like, for example, any function that deals with a Sudoku grid wants to return 81 things. It's pointless to just get them one at a time. That would be a stupid way of programming. Those 81 things all belong together. Now, if the 81 things are all the same type, we can put them all together in an array. Yeah? So that's one way of passing around big lumps of data, though it is actually slightly problematic for C to return arrays. How else could we... so I've got two questions. One is, how else could we return a lump of data? One, how else lump data together? Strings, yes, strings lump it together, but strings are really arrays, and they all have to be characters. There's got to be some other way of lumping data together. So that's the big question we're going to answer. But along the way, we just did raise a little side question there. I said, you know, it's hard for C to return an array. There was a tute exercise on that, wasn't there? I'm not going mad. We had a tute exercise where we had to work out why it was bad for C to return an array. Or have I not ever done that? Was it just in my mind that I was going to write a tute exercise like that? Okay, so let's think about why it's bad for C to return an array. We'll just do this super quick because it's a bit of a diversion, but it's an interesting one. Here, suppose I've got a function that goes, oh, I've got a function called make Sudoku. And suppose it's going to return a Sudoku grid. This sounds like a fantastic one. And it doesn't take anything in. Oh, this would be nice. I could do all the reading inside this function maybe. I wouldn't need to read Sudoku grid. So what I'm going to say is something like Sudoku grid. And then I'm going to say something like read grid. Oh, what's it called? Read game? Read grid? I never remember that. Read game grid, and then I'm going to say return grid. And doesn't that look neat? There's a problem with this, a diabolical problem, that once you've seen it, it's just going to be so glaring and obvious, and you're just going to say, oh, no, that's disgusting. And until you see it, you're going to go, that looks completely okay to me. What's the problem? Well, let's go back to our model of what's happening inside C. Let's jump to assembly. What happens as soon as we see this? We're executing and we see this, say, or at compile time, or at some time, we see this, what's going to happen? It allocates memory. It sets up some memory for Sudoku grid. How many bytes does it set up? 81. Ready to put characters in. What's in there at the moment? Rubbish. Okay. Where are those 81 bytes located? In the stack frame. In the stack frame for what? Make Sudoku. Now we replace the rubbish with real values. Then we return, and we're returning a pointer to that area of memory. What's the problem? It gets destroyed. What happens when we leave our stack? Everything gets destroyed. It's all gone. So you've passed back a pointer to an area of memory that's now been destroyed. And other things will be written there. Does that make sense? That's a terrible thing to do. So we did have this rule that the stack frames had to be sort of private to each function. And if they're private to each function, it works perfectly. But as soon as we pass back a pointer into a stack frame, we're in trouble. Because we leave, the stack frame dissolves behind us, and we're handing someone a pointer to the stack frame, and it's gone. And so, you know, someone else is going to write something really important in that stack frame, and you're going to write to the grid, and you'll overwrite the important stuff they've got. Or they'll change something, and your grid will suddenly change, and you won't even expect it. Does that make sense? So that's why it's problematic to return an array. And I believe the compiler doesn't let you do it. Is that right? You can return a pointer if and it trusts you know what you're doing, but if you try and return an array, it'll be very unhappy. Okay, so how else can we lump data together? Well, let's ask an even bigger question. Before we wonder how we can do something, probably a more important question to answer is, why would we want to? Can someone tell me, why would we want to lump data together? And why would we want to return multiple values? Okay, maybe it's efficient to answer numerous questions at the same time. So that's a good answer. But I reckon there's an even better answer. That's a good answer. That's a good reason. There's an even more compelling reason why we want to lump data together. It models the real world better. How much more convenient it was when I was writing the Sudoku solver, when I could say, oh, and I've got a Sudoku grid. And it was just one variable, and I called it the Sudoku grid. Even though it was 81 things, I didn't have to think about that. I thought of it as a Sudoku grid. Later on, when you're playing a game like in, what do we have? The Fury of Dracula, the game we had a couple of years ago that the students had to program, they had Dracula. He was a character in the game. And he had all these qualities. He was in a certain spot and he had a certain amount of health and certain numbers of minions to help, and he had stakes in his heart. He had various pieces of data associated with Dracula. But we had a variable called Dracula. And we could pass Dracula around and he had all that data attached to him. It was very convenient. So I could say, if there was to be a fight between Dracula and Van Helsing, okay, I could have a function called fight, and I could say, fight Dracula, Van Helsing, close brackets. And they would fight each other, and I wouldn't have to pass all the data in separately. I just regarded Dracula as this sort of unit that contained all these pieces of information about Dracula. How strong he was, where he was, what time of the day it was, how much garlic he'd had for lunch, all that sort of stuff. So it's very useful to lump data together, because that way we can model the real world better. Like, is it Robert? Yeah, like Robert said, it's very convenient if your program models reality better, because it's more likely to be correct, and you can think about it in a higher level. So we want to put it together and see if you want to put data together. You've got two choices, essentially. Well, three, but two at the moment. One is an array where you put a whole lot of identical units together that all have the same sort of meaning, and they've got the same type, and they're sort of related really closely. And if you've got an ad hoc sort of bundle of data that you want to join together, we've got something called a struct, which is short for a structure. And this is data structures. Structures are really about how you put data together. And a struct in C looks like this. You say struct. You give it a name. You don't have to, but in this course, let's say we always give it a name. So we'll go struct Dracula. Well, let's not say Dracula. We'll say struct vampire. So now we can have multiple vampires. We could have a Dracula. We could have a Angel. Oh, yeah. Okay. Yeah. Or Buffy. Was Buffy always a vampire? Did that ever get revealed in the last episode? Did you? I don't want to spoil it for you. No, just pretend I didn't say that. Okay. So we got struct, vampire, and then we do squiggly brackets, and then we say all the things that a vampire has. So a vampire has, I don't know, what does he have? Teeth. Int teeth. Int fangs. Thank you. But he has teeth, but we don't care about them. Now that we've got fangs, we're more interested in them. So he has a certain number of fangs. What else does a vampire have? Blood. What? Blood. He has a certain amount of blood. That's a float. Let's say that's just really macabre. He's floating in blood. Okay. He's got some blood. What else does he have? What's that? Anemia. Anemia. What's anemia?
Like low levels of iron in their blood.
Oh, anemia. He's got anemia. Yeah, that's right. How much float? How much iron does he have? Yeah. And he might also have things like his location, where, we could call that where he is now. How would we describe a location? We could say a location is maybe it's XY coordinates or GPS coordinates. What am I going to want to do? No, I don't want to think about it. That's what I'm going to want to do. I'm going to want to abstract it. So I'm going to say location. Someone somewhere else will work out what a location is, or I will later on. So he's going to have a location, and an amount of iron, an amount of blood, an amount of fangs. No, that's it. That's a vampire. A vampire contains 4 pieces of information at the moment. Now, in C, if I wanted to make a vampire, it's actually slightly annoying to use structs. So after a few iterations, people developed a new way of doing structs. And that's what we're going to do in this course. We're going to say typedef struct vampire is for henceforth going to be known as a vampire. Let me do it the other way around so you can see both. So this says, typedef, so remember, wherever we see this type from now on, we really mean this. And C knows, so long as we've already defined this, that wherever we see, oh, in fact, we don't even need to have already defined it. Wherever we see struct vampire, we mean this struct. Notice the word vampire appears twice. It's very annoying. This one here is called the tag, and it belongs to this struct, and this has to match that. Then there's a typedef where we say struct vampire henceforth will be called vampire. And it's convention, you try and use the same name, but you could call it whatever you want. In fact, sometimes people, this is called the tag, so sometimes people call this vampire tag. Yeah, and then you put vampire tag up here. We'll never get that. He's flown away. But does that make sense? Yeah, it was a question. I saw someone waving their hand.
Yeah, why, if you use the
Why don't we what?
If you use the same name, like vampire twice, why wouldn't it like screw up the logic?
Oh no, because they're sort of got different. They're in a different context. They've got different meaning. So in the place where this word's appearing after the word struct, it's expecting to see a tag. And in the place where the other word's appearing, it'll expect to see a type. So now to create one of these guys in my main program, main, I just say vampire, and we'll call him Drac. And now memory is set aside to store a Dracula. How much memory is set aside, by the way? Well, it sets enough aside to store one int, one float, and one location. I guess we don't know how much that is. So it's going to store a couple of bytes. It'll be a biggish chunk of memory set aside. Okay. Does that make sense? Later on, you'll see, in fact, later on, next week, see the word vampire that I've drawn squiggly lines under, our new type? Whether it starts with an uppercase or lowercase letter is going to mean something really significant. At the moment, all our type defs are having lowercase letters. So, and that's a lowercase v. It might not look like it. Next week, we'll see what we're going to do to make them go uppercase. It's going to have a special secret meaning. Now, does everyone understand enough about structs that if I start putting them in the tutes and labs next week, and you get some exercise about them and you get to play with them, it sort of makes sense? Yeah, you will have to play with them to use them, and I'm hoping this weekend you'll play with them after your physics exam and having rainbows and sunshine and dancing. Yes?
I was just wondering, if with the struct, you have to define what each one is. So like if you wanted blood to equal 10, you have to define it for 10.
Oh yeah, good question. This sets memory aside for a Drac unit. What information is stored in that memory at the moment? Rubbish, spam, yeah, ads for stuff. What if we wanted to set the values? We'd have to set them explicitly or put initializers. Don't worry about that. We'd set them explicitly. Let's set it explicitly so you can see the syntax for setting them. You go Drac dot fangs equals, how many fangs does he have? 7. I was thinking that number 2. But it doesn't make sense. I think it's 4. But it'd be good if he had 7. And then if I wanted to talk about how much iron he's got, what would I say that? Drac dot iron equals 0.0. Okay. And actually it was a really fun assignment. We got the tutors to play Dracula and the students to play the hunters. I think, is that how we did it? I can't remember, or did we do it the other way around? Yeah. I thought it was better the tutors were being chased rather than trying to kill their own students. It was enormously fun. We had a very fun assignment. That was in, what course was that in? 1921, which is now called 1927. So next semester, that's the sort of level of stuff. Okay. So that's struct. Thanks for that question. It was good. Any more questions about structs?
You just replace struct vampire tag with vampire when you define the struct.
Why can't we just replace struct vamp? I'll get a pen. I'll get a piece of chalk. You can have purple chalk for your answer. All right, ask the question.
If you're going to have vampire meaning struct vampire tag all over the place,
Yes?
can't you just have vampire instead of struct vampire tag in the defining area on the right side of that board you're at now?
Here?
Yeah.
No. Good question. I see what the question was. The type def means whenever you see struct vampire tag, it really means the type vampire. And he said, well, if it really means that, can we just put vampire in here and it will think it means that? And the answer is no. Well, I've got to make eye contact with you. The answer is no, because it's not the same as hash define. A type def's different to a hash define. You could type hash define vampire, hash define that to be struct vampire tag. And then you could use big uppercase vampire everywhere. When I'm saying you could, don't do that. But it would physically work. But a type def doesn't just arbitrarily replace words wherever they appear in the program with what it's type defing. It replaces one type with a sort of symbol meaning that type. So struct, struct vampire tag would have to be, I don't know, try it and see. But I'm reckoning that's not going to work. It's more a hash-defining way of doing it. But I see what you're saying. I mean, it almost could work, couldn't it? But I don't think it will. Try it and see. See what interesting error message you get, and file that one away, because I bet that's an error message you won't see very often. So it is weird, because first of all we set up our struct, and if it works, make sure you tell us. First of all, we set up our struct, saying what the struct looks like, and then we give it a decent name. And then henceforth, we only use vampire, or whatever is in that spot with squiggles. We only use that, and we never use the word struct again. OK. Now, I think that was all I wanted to say about structs. Let me just put the snake puzzle back up. Can you see it? Have I, oh, we started all that code for nothing, didn't we? Because I never actually did it. You could have been. I just didn't want you to looking at the puzzle, having fun while we were working. So you had to work out how many long it was. And we've done tuples, which are structs. Tuples means putting things together. I've talked about stress already. I have a question for you, and then we're going to have an extension lecture. And it's going to be a real extension lecture today, because I thought about it last night, and I was thinking, I'm sick of just spending all our extension lectures just doing work. We should be having fun. Extension lectures are the best part of the course. So I made a vow to myself last night that I'm not going to do any more bloody non-extension lectures in extension lecture slots. Extension lectures from now on, we're just going to have fun and muck around, and it's just going to be fun. So we're just going to have fun and muck around after the break. Now, I did want to show you something, and this will be during the break, and I wanted to set you a puzzle to take away in case you're leaving now and not going to watch the extension lecture. The puzzle is this, and it comes out of a post that someone did on the forum. In task 2, we've set up a fairly elaborate structure. Once you realise what task 2 is asking, I'm sure it comes to everyone and they go, is that all? And then you probably think, why am I doing all this work? Like, why did we even do all this? Why didn't we just do it in one little file? Why have we split it into 2 files? Why have we set up this type called Sudoku grid? Why do I have set cell and get cell? I mean, they're ridiculous functions. Why don't I just do it directly rather than doing it through a function call? Why have you given me all this extra mechanics to solve this task where I could just throw away all this stuff and just solve it directly? And whenever you say set cell in your code, why don't you just say, like, write the value into the array? It takes even less space than saying set cell. And that's all set cell does, is write it into the array. So why do we have this? Are you just trying to make it more complicated? It's a whole lot of extra work. And my question for you to think about over the weekend, why do you think we got you to do all this extra work? I don't know if I want you to write the answers on the forum or not. I don't really care. I guess you can. But I'd rather you not. I don't want the tutors to answer it, though. We'll have to tell the tutors. Because I want you to think about it yourself. Because this is really going to be the key concept in the course, once you get it. And you won't be able to have a chance to get it yet, because we haven't shown next week it all happens. But I'd like you to think about it this weekend as like a pre-warmer. See if you can work out, in advance of me telling you next week, why we go to this annoying extra work. What on earth is the benefit of it? And there better be a bloody huge benefit, because the amount of work is extremely annoying. And it turns out there is going to be a huge benefit. Pretty unbelievable benefit, in fact. OK. Now, so we're going to take a break now, and I wanted to show you a clip from one of my favourite movies of all time. You got to guess, unless the name's still showing up there. And this is, I think you're now at this age where you're choosing your future life. You're thinking about what sort of person you want to be. You're thinking about what sort of career you want to do. You're thinking about how you're going to deal with stress and work. You're working out if you want to be honest and get low marks, or dishonest and get high marks. If you want to be a stress head and get high marks but not learn stuff. If you want to learn the stuff you're interested in and get low. Do you want to be a computer programmer, or do you want to be in commerce and making lots of money? Do you want to be a politician, or do you want to help the world? You're thinking about all these different issues about where you want to go. And there's this one film that I think sums up really well the potential, the downside if you perhaps decide to live a more conventional life and don't really question what life's about. You could end up being a person that only lasts 50 times a day. And here's the movie, so let's just watch it. Anyone that wants to go can go. In 5 minutes' time, we're going to resume and start talking about randomness, is our topic for today. And let me put this clip up. Did anyone find a wallet? Whereabouts were you sitting? Go and look in that spot now. Can everyone just look around them? We've been in here since 11 o'clock. So, and these guys are very honest, they're always getting stuff in. So, but unless someone in your course took it, I reckon you'll find it. What's that? What, we've only got what? Oh, we started at 1, not at 11. So, do you want to look around a bit more? You keep looking around while we're watching the movie, and then in 5 minutes we'll have all the lights on. You can watch around, look around as much as you want. And if you go in that aisle, just do be careful because there's a camera sort of propped on the edge. So be careful. Yes, question?
If I leave now, does it mean that I stole the wallet?
It's this man here. And that man. Oh, and someone, that reminds me, someone did hand in a pencil case. Did someone lose a pencil case last week? Yes, a black pencil case. I have it. I keep forgetting to bring it. If I didn't bring it now, come back with me to my office and I'll give it to you. Someone else handed that in. Okay. Any luck? No, it wasn't you. It was him. Sorry. So I hope not. Any luck? Ask at security, they'll know. If another lecturer's found it, they'll take it down to security.
Oh, okay. Where is it around?
Where is security? E-Spot. Where's that? Near the Red Centre? Yeah. Yeah. So if someone's handed it in, it'll be there, and they'll probably say, no one's handed it in yet, but try again tomorrow. I don't know what your chances are, but your chances are pretty good. If it's only first years using it, first years are really honest. So good luck. And the other thing to do is look in bins nearby, because sometimes people get the wallet. No, they rip the money out, but they throw the wallet away. And then you get all your cards and everything back, which is a real pain. Yeah. Okay, good luck. All right, let's go. Shh. We're just going to watch this for a few minutes. Stretch, move around, stretch your leg.
That's my stretch.
That was a good stretch. I took it to the wrong point. It's 1 second further on than this. Shh. This could be Shaun of the Dead. I don't want to give it away. Come on, hurry up.